And we're here today to talk about developing and testing Spark ETL pipelines without risk against production-like data. And considering the fact that everybody joined here, I think it's pretty obvious that this is something that is important and interesting. And we have a few examples of why testing is important and why testing against real kind of scenarios is important, and why integration testing are important, and so on. These are real life scenarios. At least the one on the right happened to one of us here, at least once. Apparently this is pretty difficult to do in the world of data pipelines. So Amit, I don't want to embarrass you, but you've been doing this for a while now, working in the data engineering space. Can you walk me through today what you need to do, what you go through when you need to test? Like, you modify the new pipeline, you need to test it. What will you typically do?
Yeah, normally I'll create let's say if I have a separate storage environment, I'll create a separate bucket, let's say in S3 or any blob storage, and copy sample some data from my production environment. It's hard to copy full production, so I just sample it. Then I point my ETL job to the private, this testing bucket, and then run my test multiple times, make sure everything works with the sample data set. And then I move my ETL code to the production, and hoping that everything will work fine with the large data set in production. Normally, it doesn't go that way. Things break in production. So that's the challenge I face all the time.
Yeah, look, this is a long manual effort, and obviously we speak with people every day, and we walk through these kind of manual efforts that people go through, separating readers and writers, or maybe sampling data. Or if you're lucky, you have someone maintaining like a somewhat similar environment to you that's never exactly like production. And now I wrote this new retention job that has to finish in an hour, and I need to test this somehow, and it's really, really complicated. And the more there's manual steps and the more this takes time, it means that maybe at the very end, you already need to resample the data. And of course, every step is just another a probability of failure. It's just another chance of something to break. And that's kind of the world that we live in. And today we're going to discuss a better way to do that with lakeFS. lakeFS is something that you can spin up really, really quickly. Actually, before I go and review lakeFS, I do wonder if any one of you use, or how many of us here use lakeFS before. So if you can answer really quickly, that will be helpful. So we will know how much to go into details. So thank you for taking the time and answering. So we'll know whether or not we need to go in details or not. Appreciate it. But the brief overview of lakeFS is that it sits on top of an object store. That can be Google Storage, Azure, Blob, AWS S3, or any type of object store, even on-premise, MinIO, Daily CS, anything that supports S3. And then it provides a Git interface on top of the object store. So branch, merge, rollback, and so on through an API. So the ecosystem of tools that we have in our environment can either access the object store regularly, or can go via lakeFS and get those versioning capabilities that we will get from a Git. And then the refactor that we made a refactor that is very, very easy. We did it in a way that if before you were accessing a collection on a bucket, now you will include a name of a branch or a commit identifier, like prod, test, dev, and so on and so forth. And then the Git actions themselves, you can run them through a Python code in a notebook like you see here, or through a web interface, or through a command line interface like lakeCTL. I do see a question that was posted anonymously, so I'll repeat it here. At my company, we have Delta Lake and Microsoft Azure. We have dedicated subscriptions for dev, test, and prod, and I'm wondering if lakeFS is able to work also in a setting where dev and prod are stored on separate storage accounts. That is a phenomenal question, especially since the answer is yes. and I can give even more details than that. So just to answer this question, yes, lakeFS allows you to create isolated testing environments against production-like data. But in general, the lineage in lakeFS is available even if you separate your entire environment. Amit and I actually have in the same sample repository that we're going to share here, there's another sample that talks specifically about that. We see two very common use cases where infrastructure needs to be separated. One is the medallion approach, if someone has bronze, silver, and gold. And the other is the development approach, if you have prod, test, dev, and we have solutions to both of those things. So I hope that answered the questions. And if there are follow-up questions, please go ahead and ask. Fantastic way to start. So thank you, anonymous asker. Once we have Git, though, working and testing the environment becomes a lot easier, right? Because we can take an environment, branch out of it, develop against that production separated environment. And then something that we are not necessarily speaking of today, we can also promote the data. And that kind of talks about the last step that Amit, you spoke about in your previous overview, which is over here. When we sorry about that, guys. When we promote, I don't know what's going on here. When we when we promote data, when we promote code, we don't promote data. Right, so typically when I'm done testing my ETL, I will go and I will take the code of the ETL and I will promote it to production. So even if you have completely separate environments, prod and test, what lakeFS allows you to do is first run the ETL in isolation, even completely directly on prod, and then promote the data into prod. That obviously takes a lot less time, it's a lot less manual effort, and the probability of failure is much lower, even in the case of completely separate prod and test environment. Okay, so that's kind of an overview. I want to, as quickly as possible, switch to a live demo. Amit is going to walk us through start to finish how to do this with lakeFS using a sample repo. Amit, you want to take it from here?
Yes, and with the poll, I saw that most of the people haven't used lakeFS in the past, so I'll try to go slow and explain everything. So hopefully it will be very clear. So let me share my screen. Okay, and let me hide my controls here. Okay, so for this demo, you require the prerequisite is you need to have Docker running on your laptop, so you can run this demo locally on your laptop. So I have the Docker already running. And the next prerequisite is to have a lakeFS server. lakeFS server you can spin up very quickly in the cloud with sign up. So if you click on this link, demo.lakefs.io, it will take you to the lakeFS cloud where you can register. And once you register, let me log in with I already did the registration, so let me log in with my login account. You can log in with your email address, or you can log in with the organization space that you provide when you register. Like when you go back here, when you register, you provide your email address as well as the organization space, which can be your company name or something you want to, you can remember. And then when you come back and re-log in into lakeFS Cloud, you can either log in using email or using the login organization space. So I already registered for my lakeFS Cloud environment. So let me sign in. I just signed up today. So when you register, you'll get a verification email like this. So you just click on this to verify your email address just for security reason. And once you log in to lakeFS Cloud, it will automatically provision a lakeFS server for you. So it's kind of a playground environment where we provide the server as well as the storage bucket where you can play or test lakeFS. So in this case, when you log in, go to the clusters, and here you will see your either it will be the ready state or maybe provisioning when you log in for the first time. The provisioning takes about 10 seconds. So once it gets provisioned, click on this link and it will take you to the lakeFS server environment. So the first one is the lakeFS Cloud Admin, where you kind of provision lakeFS server. You can add your lakeFS server or instances in future, pointing to your own storage bucket. So once your testing is done, like you like it and you want to test it against your storage bucket, you can do that too. And once you log into lakeFS server, by default, it provides the sample repository, which helps you with the sample some data sets, so you can do all your testing, and it will walk you through how to get started, how to use lakeFS. So I'm going to skip that and go to my repos here. So what I'm going to do is like start from create a new repository, and I'll walk you through everything, all the step by step, how to do that, and also run the demo or sample demo. Okay, so that's the kind of prerequisite, starting your signing up for the lakeFS cloud and joining to your lakeFS server. The next thing is to clone the sample repository. So we have multiple samples in here, like a lot of demos are here, like if you want to use Delta Lake, Airflow demo, hooks, and today I'm going to focus on Spark demo. But another one question somebody was asking about it, the question was that if they have multiple environment, dev, prod, and test, and they have different buckets, there's another sample for that, demo for that, where you have multiple buckets and multiple environment. So if you are interested, you can try that too. But today I'm going to focus on this multiple samples inside this samples repository, and I'm going to focus on this Spark demo today. And to install this, like this demo as a container, what you'll do is you'll git clone the repository, the samples repository. So I already cloned the sample repository. So it will take about like a minute to download the clone the repository. So I already did. And then you just follow these instructions here, how to set up. So let's go to this particular folder here, using this multiple samples inside the sample, and then create the Docker container. So just copy this command and run this. It will build the container for you, and then run the container. When you run it for the first time, it might take a few minutes to download all the images required. But in my case, I already ran it earlier, so I have all the required images. So it took me a few seconds. And once the container is running, you'll see that this is the name of the container, lakeFS Spark Python demo. So so that's kind of prerequisite so far. You basically sign up for lakeFS cloud, clone samples repository, run this sample demo as a container. And once that is done, then you click on this repo, this URL, and it will take you directly to the Jupyter Lab UI. So this container includes Jupyter Notebook or Jupyter Lab, as well as Python, Spark, and Airflow, and lots of other things in the same container. So you can test different types of demos we have here in sample. So let's log into this Jupyter Notebook here. And as I mentioned earlier, there are multiple notebooks or demos here, but today I'm going to focus on Spark demo. Let me hide this. Make the size bigger. Okay. So far it was just a setup. Sign up for lakeFS Cloud, create the Docker container, or clone the sample repository, create the container, and then go to the Jupyter Notebook. Anything else either you want to add, or I missed something?
No, I think this is great. So this is basically representing the beginning, right? So you have a lakeFS server, and obviously you have, which took 20 seconds to achieve, and this we're trying to imitate the way that you would work with your notebook, whatever that may be. And this can be Databricks, if someone mentioned Delta, or anything else.
Mm-hmm. Okay, so in this notebook, first thing, we are going to set up some variables to connect to like a lakeFS server. In this case, you can change the lakeFS credentials based on your credential you will create here. I'll show that. So if once you go to the lakeFS server environment, go to the administration and click on create access key, which will give you the access key and the secret key that you can take and use for using this credentials here, specifying the credentials here, and also specify the lakeFS server URL, which is this particular URL that you will use. So with till here, till cloud.aio. So let's do that. So I'll take this lakeFS URL, and I already have the access keys with me, or let me create a new one. If you forget, you can just create the new access key. Copy this here and get the.
This is also a live demo why access key management is important.
Okay, so just specify those things in the variable, which we'll use to create connection from Python to lakeFS server. And the next thing is to specify the storage. Where are we going to create this repository for this demo? So what I mentioned earlier, that when you sign up for lakeFS server, we provide our own storage bucket, so you can test lakeFS. So in this case, this is the storage bucket or storage bucket that we provide. So you can use the same storage bucket. Just copy this, and inside that storage bucket, you can have your own like subfolder you can create. So let's say in this case, I can create Amit. I'm going to create a Spark repo. So that's my storage namespace. So again, you can just use our bucket provided by us and just add a prefix or subfolder with inside that. But you can also link to your own storage bucket if you have, and that's a separate discussion. We can show you later, like how, if you're interested, we'll show you how to connect to your storage bucket. But for time being, let's use the bucket provided by us. And then let's specify some versioning information. So I'm going to create the repository with the main production branch called main. And then I'm going to create a separate branch called experiment branch, where I'm going to test my ETL, experiment with my ETL. And if I'm happy and everything looks good, then I'll merge that into production branch. And in my ETL job, I'm just partitioning some data set. It's a very small ETL job I'm running. And for this demo, I'm using a CSV file, which is also included in this container. So this container includes everything required for this demo. Okay, so let's set up those variables. The next thing is create the lakeFS Python client. So we provide the lakeFS client, which is also installed in this container. And here you point it to the lakeFS endpoint, which we set up in the beginning as a variable here, as well as access key and secret key, and then create a lakeFS client. So we can connect from Python to lakeFS server. Next, we are going to create a new repository. So by default, you have a sample repository there, but I'm going to create a new one. So let's call this maybe my own Spark repo. So let's define.
So, yeah, sorry. So we ran these five blocks, and now we're ready to. We have a lakeFS server up and running. We're ready to use Python code to create repositories, branch, merge, revert, rollback, read data, write data. Really quick setup. So just for the folks on the line, right? This is how quickly you can get up and running with lakeFS. By the way, if you choose to and you want to use lakeFS, you can also spin up lakeFS OSS as well directly from from following our documentation as well, which is another option.
Thank you. Yeah. And so all these commands I'm going to run through the notebook. You can do everything from the UI also, like for example, creating the repository. You can create from the UI or creating the branches and everything you can do from the UI. And I'll show you that during the demo. So the first thing, I'm going to create the repository, and my repository name is this Amit Spark repo, and I'm going to use this storage namespace variable, which I set up earlier. And I'm going to create my source branch or the main branch as a production branch in that repo. So if I go back to my UI and refresh this page, so now I have my new repository. It's a blank and it's pointing to this storage namespace. Again, the bucket, we provide the bucket, and you can just add the prefix at the end to create a new repository. Right now, this repository is empty. So what we are going to do next is upload some data. You can either import the data or you can upload the data. There are two different options. When you import, you can import from your, let's say, your storage environment, and we don't copy the data. We just copy the pointers or the pointers to those files in your storage bucket. So let's say if you have terabytes or petabytes of Lake, when you import, it will take like a few seconds to import all those objects, because we are just getting the metadata or pointers for those files. We are not copying the data. And when you upload, you can upload the objects from your laptop or somewhere another, or if you have somewhere else in the S3 or locally, you can upload those objects. And when you upload those objects will get stored in the storage bucket that we are using for this repository. So there are two options. You can, if you have your existing storage bucket, your object store, and you want to just use that, you can just import all the files. Or if you don't have the existing bucket and you want to use the same bucket where you want to keep everything in the single bucket, then you can just upload the object into this bucket. Okay, so that's the next thing I'm going to do is upload a file. As I mentioned, I'm just going to use the CSV file as I just specified in the variable. So just upload that CSV file. If I go back here, right now, let me refresh this. So I uploaded this to my main production branch. So this is my CSV file. And you can quickly look into this. So we have the integration with DuckDB, so where you can run the queries against any data set. In this case, like CSV file, Parquet file, those things are supported by DuckDB. So this CSV file has only one record with 5 columns, a very simple CSV file to show the demo. So now once you have this file uploaded, you can commit your changes. So when you commit, basically, it will become kind of, you can look into the commit history here. Like in this case, I added my first file. So when you commit the information, you can provide the message, metadata along with that. And this will tell you what changes happen in that particular commit. So in this case, I uploaded a new file, which is in green here, the new file in that particular commit. Okay, so next thing, I'm going to read this CSV file using Spark. So let's say I want to do some ETL processing using Spark or running some pipeline using Spark. I can use Spark also. In this case, I'm using a gateway, S3, a gateway to connect from Spark to lakeFS server. Again, I'm specifying the lakeFS endpoint, secret key, and access key. But we also provide another lakeFS client also. So you can use either S3 a gateway, or you can use lakeFS client to connect from Spark to lakeFS server. Once you get connected, once you make connectivity, then you can read data from lakeFS repository. So in this case, as I mentioned, I'm using S3 a gateway, and you can specify the repo name. And the branch name. In this case, I'm using the main branch and the file name. So as you mentioned earlier, that there's some refactoring you have to do when you basically add the branch name in this case to point to the file to get the data set. So again, this is just single row CSV file, and I just created a data frame by reading that file.
Just to interrupt you quickly, Amit, there were a bunch of questions in the Q&A, which I think I answered around how to set this up, asking us to repeat the commands to build the Docker file and so on. Maybe just can you go to the presentation, the very first page for a second, just to get
okay.
The very first page, right? If you want to quickly scan this upper left barcode, that will take you to the sample repo, and that has the command lines that you can copy, which are the two command lines that are written over here. So you can copy it directly from there. You can either scan or go to https go.lakefs.io/webinar sample with a capital W and a capital S. Sorry, sorry for the interruption. I think though, I just want to make sure that the folks that want to follow up with us can.
Yep. And we'll also send this information via email after the webinar. Okay, so let's go back here to the notebook. Okay, so far what I did, I created the repository in lakeFS, then uploaded my CSV file. It can be any kind of object. It can be images, whatever. We support both structured and unstructured data. So you can upload any kind of object you want. And then I just created using a Spark to read that CSV file and create this data frame. Next thing, let's say I want to do some ETL and change my ETL job, and I want to do in isolation in the test environment and not in the production environment. So what I'll do is I'll create a separate branch. So if I go here, right now I have just this main production branch, but I want to create an isolated environment, so I can just create a new branch from the UI, or I can do that from the Python API also. So first, let's list the branches. As you saw, we have just one main branch, and now I'm going to create a new branch, which is a new branch is the variable which I defined as the experiment one. So this creates a new branch. So if I go into here and refresh this, so now I have my experiment one branch created from main. And so as you can see right now, both the branches are pointing to the same commit. What that means is both the branch have the same data set, and we haven't changed anything. So both the branches are pointing to the same data files. In this case, just one CSV. But let's say you have terabytes of data, millions of objects. When you create a new branch, it's a millisecond operation because we are not copying the data. It's a zero copy operation. We just maintain the pointers. So in this case, like both the branches are pointing to the same commit, and then that commit points to the same number of files or same number of objects so far, because we did not change anything in my new branch. Okay, so let's do the next. Let's say I want to partition my data, but I'm going to do in my new branch only. And in that case, I'm going to write to the new branch. So here, when I write, I can specify my branch name. Instead of copying to my main production branch, I'm writing to my new branch and partitioning, in this case, by first column. So now if I, let me also just look at do the diff. I am going to check the difference between my main branch and my experiment one branch, where I'm testing this, let's say, ETL job. So it will tell you what changes happened. In this case, I have partitioned my data. And then let's say if I'm happy with this, I'm going to commit my changes. I'm not committing into the production. I'm just committing it to my new branch. So normally when you have long running ETL jobs, you might commit often, like after each step. So you have full lineage. And when you commit, you can specify any metadata you want. Let's say you have your ETL code in the Git repository. You can link to the Git repository. You can add that link URL for that Git code here, or any kind of metadata you want to attach, you can attach when you commit. And then you can, again, you can do the diff from the, compare these things from the UI also. Now, if I refresh my branches here, you'll see now my commit is different for this, my experiment one branch from the main branch, because I made some changes in this experiment one branch. So now I have new commit for this one. And when I can go and compare from the UI also, compare main to my experiment one branch. And it tells me that now I have partitioned my data. And this is the file, it's successful done. And then you have the new CSV file which got created by partitioning the data set. So anytime if you see green color means it's the new file, red is got deleted, and yellow means they're like if you have a folder and there are some changes inside the prefix of folder, then it's in yellow color. Okay, so far I tested my ETL code in my new branch, and I wrote to my new branch, I commit my changes, and let's say my ETL job is done. And now I'm satisfied with I did my testing with my full production data set. And I did my scalability test, all the different tests I want to do. Now, once I'm satisfied, I can merge my data set. I can merge my branch, experiment one branch to the main branch. Or let's say if something goes wrong, you can just delete the branch. You don't have to worry about cleaning up. Just delete the branch. In the background, we run the garbage collection, which will clean out the files also, deleted files. So in this case, let's say I'm happy, I'm satisfied, I'm going to merge my changes from my experiment one branch to the main branch. You can do from the UI, or you can also do from the API, or you can do from the UI. You can do the merge from here. Let's run this through the notebook. So let's merge my branch here. So when you merge, it will create another reference point or commit ID. And you can get that commit information from the UI also. Like here, we track everything. Like if you remember, we added the first file, we partitioned the data file, and these are all the messages. When you commit, you specify those messages. And then I merged my experiment one branch to the main branch. And this is the commit ID for that particular merge operation. And next thing, after merging, if you do the diff between the main and the new branch, right now there's no difference between those two branches because I merged my experiment one branch to my production main branch. So now my both branches have the same data set. So there's no difference between those two. Now let's say you made some mistake. It was a mistake. You merged the data set wrong into production. And let's say one of the table was wrong or one of the file got wrong, and you can quickly roll back all the changes. So let's say in your ETL job, you changed thousands of files and you merged that into a production, and there was something wrong with one or two files. But before trying to figure out what happened, trying to spend a lot of time fixing one or two files, what you can quickly do is with a single command using lakeFS, you can revert all the changes. So when you revert, all the thousands of files which you merged earlier will be reverted back. So, and you'll go into your original state, a production state, and users will continue using your Delta Lake or data lake. So next, I'm going to run the revert branch operation. It's a single command. With single command, will automatically roll back all the changes. And that requires the commit ID, so you can roll back to any particular commit. So in this case, let's say I want to roll back my merge operation. So if you remember, you can get this key from here, or you can copy that commit ID, or you can copy the commit ID from here, copy ID to the clipboard. And now I'm going to revert this and roll back all my changes. So when I roll back, and if I go back here into my main branch. So now those partition data set is gone from my main branch. I went back to my original state where I have just the CSV file. But if I look into my experiment one branch, my experiment branch still has that partition data, but I rolled back all the changes from my main branch and it went back to the original state. So that's what I was going to show, like how you can create a new branch from your production data set, run all your ETL job in isolation, test your ETL code with full production data set. Once you are satisfied, you can merge your changes into production. And if something goes wrong, you can quickly roll back with a single command. Thank you. Anything else?
No, thank you. No, I think this was really, really great. Just I have a few follow-ups from comments and questions that were asked inside the Q&A. So if I can share my screen, I'll walk through those just to kind of give extra clarification, especially since I believe that there's a bunch of folks here that are new to lakeFS. Maybe worth mentioning, Amit, you called this out during your call, that when, for example, when you create a branch, it's a zero clone copy. The way that lakeFS works is that every commit in lakeFS is basically a collection of pointers to objects on your managed bucket. So the data never leaves your bucket, right? In that lakeFS server that we brought in, we bring tree versus S3 buckets just to make it easy for you to start. But obviously in real lakeFS, the data sits on top of your buckets and it never leaves it. And lakeFS only points to that data. And because the object store is immutable, we can do copy and write. So if a new file is created, like the partition files that you added right now, the next commit will point to that additional files. But branching out is a zero clone copy because we basically have another pointer to the same physical objects. And that means that this is super quick, super performant. At petabytes of lake, it's going to take milliseconds, and it also means that it saves a lot on storage. By the way, in 2 dimensions. One dimension is that now you can have 50 testing environments without copying them, and the other dimension is you can go back to historical data without creating multiple copies of the same files over and over again, because by nature in data lakes, you have a lot of static files and a smaller subset of files that are added and removed on a regular basis. But this actually expands even more one of the questions that were asked, which is, wait, I have a separate dev test prod environment, right? I cannot run them on the same physical buckets, right? And Amit called this out as well, and I also added a link to the repository that has this example in our sample repositories. But yeah, it's very common for us to work with users that have separate environments. There's kind of 2 big elements where people ask to separate buckets. One is I need to have a different bucket for my bronze, silver, gold, for example. And we can do that if you wanted to. You don't have to do that with lakeFS, but if you wanted to, you can. You can use this as separate branches on the same repo. You can use this as just separate repos working on the same bucket. There's a lot of configurations. However, if you want to achieve that isolation, you can, including the ability to export from lakeFS to like a regular kind of bucket. So just to keep in mind, that's also a way that you can achieve separations. And you still get tremendous amount of value, even if you have to have a separate prod QA test, because you can have a notebook where you run everything against QA, then you change one line and you run everything against prod in a very controlled way, and you still get the lineage, you still get the isolation, you still will run your ETLs in a staging branch within prod, and then merge the data to achieve those rollbacks that we needed before. That is a completely separate conversation that we can probably spend an hour just talking about that. But again, the link is in the Q&A, I think, that you can follow. And the last thing is just someone called out Delta. This answer is generic to many other open table formats, which is, as you can tell, lakeFS commit is across a repository, excuse me, and not for a specific table. So This doesn't only mean that you can achieve multi-table transactions, which is a great thing to be able to achieve and very important, right? The ability to not only go back in time and a specific table, but go back to the last release, right? But it also means that when you go back and you look at historical data, or you want to maybe backfill, reprocess, do a lot of these kind of use cases, the historical commit are also for multiple data sources and not only one table. Also, the isolation, branching in like long-lived branch in Iceberg, for example, is a read-only branch, right? But that staging branch that I spoke about, right? Running an ETL in isolation, changing all the data, and then promoting the data, that is not something that an open table format comes to solve, and it's something that you can solve with lakeFS. And the last thing, which we did not address at all within this session, is our Git action alternatives. We have hooks, pre-merge, post-branch, pre-commit, things like that. So you can actually run a CI/CD pipeline by automatically running tests with lakeFS before you go and you merge or promote data to production. These are all very different use cases than open table formats. I'm just, again, calling this out because this was one of the questions that was asked on the chat. Having said all that, when we use lakeFS, as we mentioned before, we get tremendous amount of savings, depending on the way that you use your storage. Again, you get way faster time to market. We have users that and customers that have blogged about this in their own blogs about how lakeFS reduce the testing time, for example, in 80%, and you never ever have to troubleshoot a production issue under fire, because we can always just first roll back, like what Amit showed at the very end of this presentation. lakeFS is open source. What we showed you today is all open source capabilities. And we also have a lakeFS cloud solution that's available, that is a hosted lakeFS environment with also some enterprise features like RBAC, SSO, auditing, and things like that, that you can learn more about it by going to lakefs.cloud if you're interested. But again, all the functionality that we showed today is a part of the open source package. If you're running on-premise and you cannot take advantage of lakeFS Cloud, we also provide those libraries as licensed software that you can achieve role-based access control and single sign-on on your internal installation. What's next? If anybody wants to try this out, you can try this with the lakeFS server that you might have spun up before. We have the sample repository that you can use as well. And we also have a tremendous amount of attraction on our community Slack. So if anybody wants to join, ask questions over there, you can do that as well. I do want to ask one more question from the people that are here, which is, was this helpful? So it will be really good for us to get your feedback if this was something that you found helpful, that can be useful for you on your day-to-day job. So that's a question that we're asking right now. I'll pause and give the opportunity to ask additional questions for anybody else here. We'll go once, go twice, and let's wait a little bit. See if there's any other open questions that someone wants to ask. No? Okay, fantastic. So Amit, thank you so much for your time here. Fantastic demo. And thank you, everybody that participated, asked questions. And we hope this was useful. And happy versioning to everybody. And okay, sorry, another question. We currently still use mount points in Databricks. Is this compatible with that approach as well, rather than specifying the full path of the storage bucket? I actually don't know. So this is a question, I think, for you, Amit. Maybe you can help me out here.
So if it is DBFS, if you use Databricks file system, basically you can read from and upload into the repository. So in one of my demo samples, I have also Databricks where I store my files in the DBFS and then read it from there and load into the lakeFS repo. But lakeFS repo will not use DBFS as the storage namespace. You will need the object store of like a S3 Azure Blob or GCS. But DBFS, you can read from DBFS and load into the lakeFS repo.
Yeah, so that would be like a manual download, upload kind of thing, supported.
Okay.
Not the best scenario, but definitely a great scenario, a good scenario to work with to still achieve versioning. Okay, any other questions? I might have been too fast before, so too quick before in setting. Okay, great, thank you for the answers. Okay, great. Thank you, everybody. Appreciate the time and hope you enjoy lakeFS. Thank you, Amit.
Bye-bye.
Talk to you later. Bye-bye.